All right, we're gonna go ahead and get started. So I like to start off and say thank you and welcome to the 2025 Forest and Climate Learning Exchange Series. Today we have our fourth webinar on monitoring, reporting, and verification. But before we get started, I like to take a moment and say thanks to our co-host. So the 2025 Forest and Climate Learning Exchange Series is co-hosted by the Society of American Foresters, which is a national scientific and educational organization representing forestry and related natural resource professionals across the United States. Founded in 1900, SAF promotes science-based sustainable management and stewardship of our nation's public and private forests. We're also being co-hosted this year by the FOSSI program, the Forest Owner Carbon and Climate Education Program, which is a collaboration between 13 university extension divisions and 3 USDA climate hubs, which seeks to educate forest owners and practitioners about the forest carbon and climate smart forestry. So today, this webinar is going to be co-moderated by myself, Dr. Chad Papa. I'm the director of the Forest Carbon and Climate Program, and I'm joined by Dr. Melissa Cry, who's an associate professor at Penn State University and runs the FOSSI program there. Before we get started today, I just want to highlight our next upcoming webinar. So on May 13th at the same time, so 2 to 3 p.m. Eastern Time, we have our next webinar, which is forest carbon offsets and implications for the forest bioeconomy. So Melissa will be leading a great panel of folks from both Appalachia State University, Michigan State, and University of Florida to talk about all the different kind of facets related to how the forest bioeconomy is being affected by the voluntary offset markets. So today's webinar attendees can earn continuing education credits both through SAF and ISA. So if you registered for this webinar with the same email as your SAF account, those credits will automatically be applied in the future. And then if you need ISA CEUs, please email us at forestc@msu.edu to receive those credits. A last little bit of housekeeping is we'll have our moderated question and answer portion of the webinar today. So if you have questions or topics you might like to learn a little bit more about, we have two ways we can do that. We have the Q&A function at the bottom of your screen where you can ask questions there. You can also use the chat function and send messages to the panelists directly, and we will do our best to address as many questions and topics as we can. Last thing of note is if you'd like to learn more about both the Forest Carbon and Climate Program and stay up to date on news related to forest carbon and climate, please sign up for the FCCP's mailing list by scanning the QR code on your screen. So the last couple things, I just want to give a couple brief overview slides about monitoring, reporting, and verification, so MRV, just to make sure that we're all kind of starting on the same page. So what is MRV? So there's three parts of that. We have monitoring, which is the actual measurements of the emission data. So today we're all talking about forest carbon offsets. So this is related to terrestrial forest ecosystems. So this could be everything from actual tree measurements out in the field or in the forest, as well as other types of remotely sensed measurements. We also have the reporting of those measurements. And so this is accurate and expeditious reporting and distillation of that data into a kind of common, easily understood format. And then the last, probably most important aspect of that is the verification. So this ensures the veracity of that reported data and ensures that it is both consistent and compliant with reporting standards. There's a lot of different ways that we can measure forest carbon and forest carbon offsets. The kind of the two biggest categories probably are going to be ground-based observations. So these are either something like a plot-based measurement, or let's say like a national forest inventory. We also have our remotely sensed observations. So this could be everything from satellite images, so optical data, to other forms, so something like LiDAR, so light detection and ranging, synthetic aperture radar, as well as something like, let's say, an eddy covariance flux system. So we'll talk more about that during the webinar today. Then oftentimes, probably the most common is a combination of the two. So taking some ground-based observations as well as some remotely sensed observations. And so the last slide I have just to cover real quickly is there are generally accepted principles related to how do we do MRV. And so the kind of 5 principles that we have are transparent. So this is a clear description of all the data, methods, and assumptions that we use, the completeness of that reporting and verification. So this is a way to also kind of ensure that all emissions and removals are estimated across time, and we're including all relevant categories. Consistent, so we're making sure that we're following consistently approved methodologies and that our observations are not artifacts of changes in those methodologies or data availability. Comparability, so making sure that we're using common formats to be able to compare across areas. And then lastly, accuracy. So this is delivered using methods designed to produce estimates systematically, neither under nor over the true value, that reduce uncertainties so far as practicable. And so we'll talk a lot about these today as we go on. And so with that, I would like to introduce our panel. Each panelist has prepared a few slides, and so we're going to go through those slides now. So I'm going to hand it off to Dr. Dan Hayes from University of Maine.
Thanks, Chad. Yeah, I'm Dan Hayes from on the Faculty of Forestry at the University of Maine up here in Orono, and I'm super excited to be here, so thanks. Normally, they choose to have the best go last, but I don't know, for some reason I'm going first. But so I will do that with just a couple slides here, which hopefully you can see. I'm gonna kind of broadly mention this idea that it's more than an idea, it's an actual program that NASA works in this space. And so they have a program called the Carbon Monitoring System. And this is actually congressionally mandated and has been a program that's been around for a couple decades now, where researchers from around the country have put together various projects that look to build these, what we call prototype MRV systems. So Chad gave a great intro to what MRV is. I've added another M there, which is maybe redundant according to the definition that Chad shared, but just monitoring, measurement, monitoring, reporting, and verification. So there's a bunch of different ways to go about this, as we're going to hear about and talk about in this panel. In our case, I work with a bunch of colleagues from the University of Maine, as well as other universities, including Michigan State University, coincidentally, as well as scientists from NASA and the Forest Service to put together a prototype for working forests. So a lot of these carbon monitoring system projects can range from anything from looking at methane leaks out of gas pipelines using spaceborne and airborne technology, to looking at other ecosystems like mangroves, agricultural systems. And so our place on this larger NASA CMS science team is to look at managed forests and how we can use various NASA technologies to do MRV. And so our kind of angle for this whole thing is because we've, as a land grant university in a state with the most forested state in the country, a lot of our stakeholders that we have a mission to provide information for and new science for are on the ground forest companies, forest management companies that own a big chunk of the state. Again, Maine is most forested, but it's also different from the West, where it's primarily privately owned commercial forests. So we have a bunch of different applications, I guess, for this kind of information. Showing on the slide is on the left, up at the state level, we work with the state on their emissions reductions goals, carbon emission reductions goals. So we provide information about how forests and other ecosystems are taking up and storing or not carbon using these kinds of tools. And then on the right shows an example of a report that we did where we're looking more at the stakeholders on the carbon project level, so individual landowners and what kind of information they need to be able to move in and out of these carbon markets and make decisions that way. So a lot of the either way, whatever scale we work at, we tend to get this question about which model we use. And model wasn't one of the M's, but if you think about how Chad introduced that, different ways of measuring, we have ground plot observations and we have remote sensing information, both of which we use here. But neither of those things actually measure carbon, right? The only way to actually measure carbon is to go out and cut all the trees down, dry them out, and weigh them, which we're not going to do. So what we do is we make measurements about trees, their DBH, their species, their height, and we also can shoot lasers at them to measure various things about the trees as well and expand over larger forests. And that's how we estimate carbon. But all of those things that we do require some kind of model, even if it's just a simple linear allometric equation or more sophisticated process models. And so that's what we're trying to capture here in terms of this whole system, is how do we put these models together, data sets together, to integrate ground plot information with remote sensing data that we can use then to make information that people need at these various scales to make decisions, whether they're trying to mitigate carbon emissions and increase nature-based solutions at the state of Maine level, or whether they're looking towards how to manage individual forest stands towards carbon uptake and maximize your carbon sequestration. So these are what we're trying to work on, is these kind of stakeholder-driven, multi-objective problems, and there's some ways of doing that everywhere from remote sensing to drive these simple bookkeeping models all the way up to fancy process-based ecosystem models that we have here. So that's kind of my introduction to what I'm happy to talk more about on the panel, and I will stop there and hand it over to the next. Thanks.
Thank you, Dan. John, do you want to go next?
Sure. Thanks, Chad. All right. Hello, everyone. My name is John Gunn. I am the U.S. and Canada Carbon Science Director at the Nature Conservancy. I am also based in Maine, about 2 hours southwest of Dan. My role at the Nature Conservancy and my team, we support our state chapters and Nature United in Canada on their engagement in carbon market activities and more broadly in evaluating natural climate solutions of management practices, mostly focused on the forest side of things, although we dabble a little bit in grasslands and peatlands on my team as well. So I'm just going to mention a few ways that MRV kind of touches down in my world, working mostly on improved forest management methodologies. And right now there's the emergence of more dynamic methodologies that move away from a static baseline as we've developed projects in the past to having a baseline that sort of changes to reflect maybe impacts of climate change or disturbance or market conditions. And so there are a couple methodologies now that are evolving to do that. Verra's VM45, which has a measured and matched baseline compared to your project, and the ACR IFM 2.1, which has a modeled baseline that gets updated periodically. And so I think for these dynamic methodologies now, this MRV, the M now applies to the baselines in addition to the project, which I think is important to note because in the project, you've got much more control over your monitoring activities, right? You're putting out the ground plots, or maybe you're tapping into satellite data to monitor changes on your project. But now with these dynamic methodologies, we have to rely on external data sources to document the relative changes in the baseline. And I think that creates some different challenges for project developers in terms of documenting the benefit that project activities have relative to some business as usual activity. So one key piece of this revolves around the timing of those updates. And so if in the US we're kind of comfortable with national forest inventories being remeasured on a sort of a 5 or 6 year scale, and that's helpful in terms of understanding the dynamics on the landscape and how things change. You start to push beyond 5 years, and it gets a little more challenging to have really relevant and meaningful claims to make against that baseline. And so timing of data that's available, whether it's ground-based National Forest Inventory data or satellite data that are being remeasured in a time frame that's useful is important. In addition, the ability to detect change becomes extremely important, particularly if you think about the eastern US here and in our Family Forest Carbon program that we work on collaboratively with the American Forest Foundation. Part of the underlying driver for that program is to change behavior of landowners and move away from maybe high grading harvest practices or harvest practices that are maybe more intense than you might want if you're trying to encourage carbon stock development over time. And so in the baseline, you need to be able to detect that change at sort of at that more finer scale and understanding changes in forest structure. It's one thing to be able to detect a 5 or 10 acre clear cut on the landscape, but to understand the volume change that happens when there's some sort of thinning either from below the canopy or larger diameter thinning from above, and to be able to detect those changes becomes important as you're trying to again demonstrate that your project practices are improving upon the baseline. And so I think related to that, and in the forestry world, we're much more comfortable with thinking about traditional forest inventories in terms of the kinds of information it gives us about what's happening on the ground. And so that it comes down to tree level data and understanding the species mix that's there. And this is particularly important in complex or mixed species forests where maybe we have some remote sensing tools that are good at measuring kind of gross biomass volumes, but don't give us a lot of insight in terms of tree species diversity or even that structural complexity vertically in the forest. And so making those linkages to traditional forest inventories gives us the ability to start to understand some of those below canopy dynamics. And I think another key piece here when thinking about these dynamic baselines is the need to have socioeconomic data that is monitored as well. And so that might be changes in land ownership on these landscapes that you're working, or market dynamics. You might have sawmills that are winking in and out of existence on the landscape, and that all is important to know and understand. If your baseline is changing, if suddenly there are no market drivers that allow harvesting in that landscape, that changes your ability to make claims about the benefits of that project. So having consistent socioeconomic data is another key piece to MRV moving forward. And finally, I think from a monitoring perspective, and thinking about future reversals or loss of carbon, I think the ability to understand the risks that are emerging, whether it's forest pests, native or non-native, or other disturbances. I think we have to be able to track those and understand what kind of management responses might be needed to support or mitigate the resilience of the forest that we're working in. And I'll end there.
Great. Thank you so much, John. Kim, I'm going to hand it off to you. So I'm going to hand it off to Kim Novick from Indiana University next.
Great. Thanks so much, Chad. Really happy to be here. I think in a way, my little bit is maybe about the missing end measurement, but I'm going to try to bring it back to the other aspects of MRV at the end. Just as framing, a lot, what I want to talk about really emerges from a much broader set of work and a couple of what I might describe as think pieces that we published over the last couple of years that basically boil down to a central point, which is that due to the fact that the terrestrial carbon cycle is such a huge control on the growth rate of atmospheric CO2, globally, we have invested enormous amounts of time and energy in developing tools, including the data tools you see here, but also models to understand those cycles. But historically, by and large, most of those tools have not been fully leveraged for what they can tell us about nature-based climate solutions or forest carbon removal. It tends to be that in monitoring MMRV context, And also in efforts to predict the mitigation potential of these strategies, we tend to rely really on a limited set of the available tools. Some of them Dan talked about in his talk, in the case of trees, inventory data, allometric equations, and a limited amount of remote sensing data. There is a lot more that we could bring into the picture. And what I want to do with the time I have left is present just a little vignette about how incorporating some of this other information, in particular information from eddy covariance flux towers, might reshape our understanding of how forests regulate the carbon cycle. And then the big question is, okay, well, so what do we do with that in the context of developing MRB frameworks? I always find conservation of mass a really nice starting point, but I think it's going to be really useful here. On the left-hand side, we have the change in carbon stored in a variety of stocks here within the forest ecosystem. And on the right-hand side, we have the balance of carbon coming in and carbon coming out. I think most of you are probably familiar with these different stocks. The fluxes, the primary way carbon enters the ecosystem is through net ecosystem productivity, the difference between photosynthesis and respiration. And there's a few ways it can leave the ecosystem, from fire emissions or harvest or losses in aquatic losses. It happens to be the case that in almost every policy and management relevant context, our understanding of forest carbon removal is informed by stock change data. And I think that this is probably well known to this audience. These are foundational tools, and they're highly scalable, and there's a reason why they are so often used in these frameworks. However, these are also tools that have important sources of uncertainty and bias. One or two to highlight is the fact that because many of these pools are simply very hard to measure, especially repeatedly, they are often omitted from the calculus. And then a second is that the carbon stored in live and dead trees is estimated using allometric equations forced with inventory data. These allometric equations are sometimes decades old, and they were not designed for the purpose of monitoring forest carbon uptake. They were designed to estimate merchantable timber volume, such that there's good reason to believe that they might not accurately represent the dynamics of non-merchantable tissues and species. So these are two things that might cause estimates of forest carbon uptake generated this way to be biased low. Okay. On the right-hand side, let's consider the case of an undisturbed forest. So there's no harvest and no fire. So we can forget about that flux and we can forget about that flux. And let's also assume that the aquatic losses are small. That's not a particularly great assumption, but let's use it for now. In this case, the primary flux that remains is the net ecosystem productivity, which in this case is directly equal to the change in carbon stocks and is something that we can measure with eddy covariance flux towers, which are capable of sensing at timescales of half-hour hours, the ecosystem scale movement or transfer of CO2 between ecosystems in the forest. Okay. So the goal of the work that we're doing, and this is preliminary, it's on its way, but still a ways to go, is a robust comparison of what these two different approaches tell us about forest carbon removal. And one aspect is to leverage data from NSF's National Ecological Observatory Network, where we now have about 8 years of co-located forest inventory data and tower data. And what this graph shows is the stock change estimates on the x-axis and the tower data on the y. And you can see that there is a bias, and it's not small. We tested different variants of the stock change approach, but in general, the towers at these sites tend to report carbon uptake that is 72% higher than what we see with the stock change approach. Okay, but this is just a handful of sites. We're working on increasing the number. Oh, sorry, something happened. Maybe not. This is now a similar comparison, but done at the regional scale. So we have a CMS project. Dan introduced that program earlier, where we are upscaling eddy covariance flux tower data to map carbon uptake in the Eastern United States. So we did that for the year 2017 so far, and then we are comparing the state level estimates of carbon uptake generated this way from the tower informed maps with on the x-axis now stock-based carbon uptake from FIA, limiting the analysis of the FIA data to unharvested, unburned plots, because most towers are in unharvested and unburned stands. And again, there is a bias. It's a little bit smaller, but still quite substantial. Especially when we consider the fact that, globally, The land carbon sink is, 25 to 30 something percent, or sequesters 25 to 30% of anthropogenic emissions of CO2, and forests represent 90% of the land carbon sink. And so, it's just, we have a lot more to do with this work, and I definitely welcome feedback and suggestions. But we've done some other work that confirms the main conclusion. I think for this particular panel is, as we move towards publishing that, what do we do with this, right? Let's say that in the end, the bias appears to be real and persistent across scales and stands. How do we develop MRV frameworks used in carbon markets or other policy development contexts that are capable of assimilating new science or new knowledge or new tools, especially when those new tools present a very different perspective, in this case, on the role that forests play in regulating the pace of climate change? That's what I had. Thanks again.
Yeah, thanks so much, Kim. That was very informative. And so lastly, I'm going to hand it off to Jason Gibson from Weyerhaeuser, and then from there we'll jump into kind of our Q&A portion of the talk.
All right, you see my screen there? Good. All right, so Jason Gibson, I'm Director of Forest Carbon at Weyerhaeuser. My background's been managing forests in the mostly U.S. Southeast over my career. Moved into this role in 2022, so been enough to get my feet wet in forest carbon. I'll start out just telling a little bit about Weyerhaeuser and why we're in the forest carbon business. So we own and manage 10.4 million acres of sustainably managed forests across the U.S. We harvest about 2% of that land a year. We plant around 100 million trees a year. We also have a wood products business that has, we have 35 wood products facility that convert that harvested timber into long-lived wood products that also store carbon. Owning and managing that land across every major wood basket in the U.S. really gives us a unique perspective that led us to launching a natural climate solutions business. So in 2021, we did that, and we really leveraged our resources and expertise to contribute to delivering climate solutions, but also, in helping others really meet their climate goals. And the four businesses in that natural climate solution space includes mitigation and conservation. So think wetland mitigation, banking, conservation outcomes for some of our land, renewable energy. We lease our land for wind and solar. Also, carbon capture and storage is one of those sub businesses. So storing carbon in a subsurface, and then forest carbon, which is the group that I lead. This is a map of our timberlands portfolio, just to help you understand a little bit of the scale here. And we decided to be our own developer, really kind of leverage the expertise of foresters with decades of experience. This is our 125th year in business. We're excited about that. But we have foresters with this experience and teams of biometricians that have been managing this land sustainably for a long time and develop better and better inventory and solutions to do that. And so that's important when it comes to thinking about MRV. Also, being our own developer creates some buy-in from our foresters on the ground, because we are developing these projects, but they're managing. And for us, it reduces some execution risk if we are developing the plans that they're going to be using to manage the projects. Really, it's one of the largest private timberlands owners in the world. We thought leveraging that experience in forest management brought our own level of integrity to help, bring trusted, high quality forest carbon projects and other natural climate solutions to the market. One important thing about our projects and how we're doing them is we're really maintaining a working forest while creating carbon additionality, because that forest economy is so important to us. We support rural communities with our business. Oftentimes, we're the largest employer in those communities from, a mill standpoint, but even you know, our foresters, the people that harvest on our land. And we were also, you know, making products that people use every day. So that's really led us to focus on improved forest management projects. We use ACRs, IFM for non-federal forest lands is the methodology we focus on. Our first project was registered in Maine in 2023. It was called the Kibbe Skinner Project, 50,000 acres there. We've since registered another project in the South. It's called the Rosetta Project. It's in Southwest Mississippi. And then we have 4 more projects right now. They're in some form of audit or under registry review being finalized. We continue to look across our portfolio to find new areas and talking to our foresters about things we could change and do different to create additionality. Just a little bit on the MRV, just thinking about project inventory and how we're doing it right now for the projects is we're putting in permanent fixed radius plots on our project. And then we remeasure those every 5 years. We're working on, you know, some process to do some interim measurements between those 5-year times. You know, one of the things that I'll talk about as we walk through this is we talk about improving MRV. You know, we already have, you know, robust internal inventory systems. I talked a little bit about that with our decades of experience. And we built growth models over the years. We don't use those in our projects because they don't really lend to fitting in with the methodology right now. And so that's something for landowners like us that would make things a lot easier, would be able to use and capture some of the value of our internal systems and reduce some of that complexity and duplication, really. That's my introduction, Chad.
Great. Thank you so much, everybody, for sharing a little bit with us. So I'm going to kind of kick off our discussion. So I think one area that has been coming back to us a lot is a need for clarity on a little bit where are we at when it comes to MRV technologies. So I'm going to kind of throw out just a pretty broad question. And so I just asked the panelists to maybe talk a little bit about where does MRV work really well and where do we kind of need to go next with MRV technologies? So like, what are we doing good, but what could we be doing better in the future?
You want me to start there?
Sure, yeah, Jason, sounds great.
Okay. First, I just recognize that, you know, the market and methodologies are still developing. We really have a great foundation to start from, and there's going to be continuous improvement in MRV for a while. We're going to get better and better at it, especially as technology improves. Let's break it down from the kind of monitoring, measuring standpoint to start with. You know, we've been measuring tree volume and forest biomass for a long time using all the ground-based inventory methods, and, you know, they're trusted and they work well. But, you know, we're at this exciting inflection point where remote sensing technologies are getting better and better. And we certainly need to increase the use of that, in my mind. You know, right now, in conjunction with the field-based data, that's going to help us be able to scale a little bit and reduce some costs, because that is a barrier here. And over time, hopefully we get to where remote sensing is robust enough to really support that year-over-year carbon stock monitoring, which is what most developers are looking for in this space. Because if we're serious about really scaling this, we're going to have to accelerate the adoption of that technology to integrate into these MRV systems. And so far, that adoption has seemed a little bit slow to us. And then on the reporting, you know, I think it's important to acknowledge, at least starting out, that project developers are already doing a tremendous amount of reporting. And the level of, you know, data transparency that's required in these projects right now, to me, is actually, you know, pretty phenomenal. There's a lot of data. That's not the challenge. It's really the accessibility and the usability of that data. I mean, you know, right now, sifting through project documents, if you just think about methodologies, monitoring reports, verification and validation reports. It really requires a team of pretty technical experts, I guess you'd say, just to interpret what a single project is doing. And so to me, that may be the lowest hanging fruit in the MRV space. We need to standardize and streamline some of this so that the corporate buyers, for instance, don't have to hire a PhD in carbon accounting to be able to buy a carbon credit. I think that will help the market to scale in that space. And then if you think about verification, first I'm going to say I appreciate what all those verifiers do. That's a tough job in this space. And so in my experience, they audit to the standards and methodologies, and it's a rigorous audit. And so I mean, we don't need to change that. It needs to be rigorous, and that's critical to safeguard, the integrity of the market. But I do worry about scalability in the current model. Much of this verification burden really traces back to the lack of standardization in the documents. Each project has hundreds of pages of documentation and spreadsheets. And really, these vary, I've found, by developer, by project type, by methodology version. So each time a methodology is updated, a lot of that changes. And that means when a verifier takes a project, he's almost starting from scratch when he starts his review. Not sure exactly what he's going to see. It may not look like the last one. So again, that comes back to the need of some standardization if we want, the verification part to scale with the growth of these carbon markets. It's got to be faster and a little bit easier to audit, because really that's going to save money too. Of course, don't want to sacrifice any integrity, but that's my view of kind of where we are and some of the things that are working and maybe could be improved upon.
Great, thank you, Jason. I'm going to pivot really quickly to a little bit more of a direct question to you, Kim. So in the Q&A, we have two questions. One being, is the delta between the flux towers and stock change data, is that standardized for seasonality? And then this kind of second follow-up question is, in your opinion, how much of that bias is maybe being accounted for from like outflows of carbon from the system that something like an eddy covariance flux system isn't really capturing, like something like a lateral transport per se?
Those are great questions. I hope that I can answer the first one about seasonality by just saying that those were annual data at the annual time scale, so they integrate over all the seasons. I'm not sure if that was the intent behind the question, but that's my best answer. For the second one about lateral losses, they are really understudied in forest ecosystems. It's really hard. You have to like build a weir and capture flows and take that water back to the lab and measure its carbon content. The studies that have been published report it to be somewhere on the order of 5 to 10%, maybe a little higher, in particularly complex terrain where there's a lot of rain. So it's not enough to explain the bias, though it's also important to note that the stock change approach wouldn't necessarily capture it if it's not monitoring changes in soil carbon, which are like really, really hard to do in forests. You need so many samples and over decades to see a significant change. I will say there are other approaches. I presented two ways to estimate forest carbon uptake. There is a third, which ecologists have been using a long time to estimate the change in carbon as the difference between net primary productivity and heterotrophic respiration, which at least implicitly accounts for what's happening in the soil. And when you compare those measurements to the towers, there's still a bias. The towers are still a bit higher, but it's much smaller, on the order of 10 to 20% or something like that. And so I think that a lot of the answer is probably in what's happening in the soils and below grounds, though I also think that those allometric equations are an important piece of the puzzle as well.
Great, thank you so much, Kim. So I'm gonna go back a little bit to that first question. And so oftentimes our ability to accurately capture these carbon dynamics can be related to the value of an actual carbon credit. So within a carbon offset market, we're assigning a dollar amount to, let's say, like a ton of CO2 equivalency or the amount of 1 ton of carbon dioxide equivalency. I'm gonna throw a question to you, Dan, and thinking about obviously there's some of these trade-offs here of using some of these remote technologies can also reduce, let's say, cost barriers to the MRV process. But oftentimes there's maybe more uncertainty or some concerns around like let's say accuracy of those measurements due to just the methodologies involved. Where do you kind of think the next steps going forward for some of these more like remote techniques to measure carbon can improve upon to contribute to the value of that carbon credit?
Okay, great question. I was hoping you weren't going to ask me though when you start talking about economics. I'm a scientist. Like, oh, we'll just figure out the best method, and somebody else has to figure out how to pay for it. Weyerhaeuser does. But that's a great question. We do think about that though, in the aspect of how to use remote sensing technologies because they're, in theory, supposed to be more efficient. You can cover larger areas, and hopefully at less cost. What we mostly work with, I think the best, or kind of the most interesting technology that a lot of people on this in the audience, I'm sure, are aware of is LiDAR, being able to take three-dimensional structural measurements of the forest in order to be able to turn that into information about biomass and carbon. So that's a real area of research and practice. I think it's almost operational in a lot of cases. So that's great, but I think what people forget is that you can't make any sense out of that remote sensing information from LiDAR unless you have really good calibration data to tie it to the ground. And so that's a critical piece. That's also costs money and time. And so we're looking at ways that, okay, if we have the same LiDAR point cloud, we need these calibration plots. There's questions about, in order to get a good model to predict biomass or carbon, how many plots do you need? Where do you put the plots? How big do they need to be? Can they be fixed radius or variable radius? Because there's trade-offs in time and stuff. So there's a lot of questions that we can look in there. And so that's a big part of the cost. The other one is the LiDAR itself. Collecting LiDAR data is expensive with airplanes involved and all these things. So we tend to not have a lot of LiDAR data. We definitely don't have as much as we want ever. A lot of times we just have one snapshot that the USGS has flown for a digital elevation model. So we have leaf off. They weren't thinking about forestry necessarily when they flew that. And so but still works pretty good. We've seen that. We can get a good measure at one point of time of volume or biomass, but that's just one of the M's, right? The monitoring, then how do we update that? We don't have any new information. So we look at other things like, can we use aerial photography? There's three-dimensional point clouds that you can develop out of photogrammetry, and that's a lot. We call that poor man's LiDAR. That's a lot cheaper. Maybe we can kind of supplement LiDAR data with photogrammetry point clouds. There's also spaceborne LiDAR that's going around on the space station. That's a little bit trickier to work with, but can we use that to help kind of update our LiDAR measurements, and would that be an efficient way? So yeah, great question. There's lots of different technology that's kind of in the works that we're testing out and seeing how well we can model these and provide this sort of information, efficiently and at lower cost.
Yeah, John, you want to go next?
Just to follow on with Dan here, I mean that illustrates some of the challenges with these technologies and incorporating them into these carbon project methodologies. There's all these different data sources. There's inconsistencies in terms of the timing and the level of detail. There's, who knows if JEDI is coming back again, and who knows if FIA is going to continue. So there are all these kind of external things that are beyond the project developers' control here, and that those will continue to be hurdles to, I think, incorporating kind of the latest and greatest science if they if they're dependent on expensive research endeavors to collect this information. That if we really want to, as Jason said, scale it up and make it mainstream, there needs to be some consistent sideboards and expectations around data availability going forward. Otherwise, we'll continue to cobble together these solutions, and we'll that creating that uncertainty within any kind of credits that we're claiming or trying to sell in the marketplace is, is a concern, as, people are scrutinizing these projects very closely. And so consistency going forward is key in my mind.
So kind of building off of that, a question in the Q&A is, how are these complex approaches to measuring carbon storage being translated for public consumption? And then there's kind of a second part of that is, how can our science, business, and public sector community, so like government, state, and federal, help improve the perception of the accuracy of these tools, specifically in a market context? And so there's a lot of things happening at play here, right? Like we have folks like some of us here at universities that are maybe contributing to the research. We have folks like Jason here on the business side that are trying to use some of these tools. And we also have some on like the public sector side, whether it's state and governments. And there's a need to inform the public about these things as well, to both improve the perception of these tools, but also maybe increase confidence in these tools, again, to support the value, I would say, of a carbon credit or within that kind of broader market context. I guess not throwing into any specific panels, but if anyone wants to jump in really quick, how can we be better about that public outreach and translating these things to the public?
I'll just I'll jump in a little bit on that question. There was a whole lot you talked about there, Chad, but I think one way is stronger collaboration. I think where research can really add value is by focusing on more real world applicability of the forest carbon projects, and really digging in and understanding the methodologies and the constraints to those methodologies. And these standards that are created that we're following are not theoretical; they're frameworks to get to get issued credits. And so aligning research and stronger collaboration between research who are looking at these tools and technologies, to project developers who are doing the day-to-day implementation, to the registries who are writing the rules, and even the verifiers, because they really know where things break down in practice. And so that kind of cross-sector collaboration could help us build more scalable, accurate, and cost-effective, I think, pathways to this. It feels like it's somewhat siloed at times now. So certainly there's just a lot of innovation to still take place in this space, and we need to bridge that gap between all those different groups to make sure that the research is matching up with that field level implementation. So that's at least an answer to one of those questions in there.
Melissa, you have your hand raised.
I just thought I would add, being the person working in extension, I often think about science communication, and in this case it'd be like tech communication as well. And I think that when it comes to communicating to the public and to non-professional audiences that don't work in the tech space, that trust should be front and center, and maintaining and fostering that trust. So when it comes to quantification of carbon at the landscape level, communicating in ways that, say, a landowner can replicate by helping them understand, how, allometric equations and stand characteristics are part of that estimation, is ways that can allow people to, verify that, we're not just measuring something magical in the air, that these are things that are quantifiable. And then when it comes to, say, remote sensing technology, of course, we're talking about big data, we're talking about machine learning potentially. And so it all has to do with privacy and security. And so who is being monitored, and, and how is that information being used? So those are the perspectives of the reader, of the public, when it comes to monitoring and verification, is really has to do with their ability to assess the risks personally, and to also sort of be able to have a meaningful discussion, because they understand at least where it's coming from. So that would be some of my thoughts on that.
So kind of building off of that, I have a question for you, Kim, and building off some of what you presented on, and thinking a little bit, how can we better develop MRV frameworks that can be flexible enough to help us think across different scales? And so thinking about if it's, let's say, an offset project, we're kind of thinking at that project level, maybe individual for a stand or site. And we have tools for that, right? But also thinking, trying to scale some of this upwards to maybe more policy relevant or larger decision-making scales. And what can we do as we develop our MRV frameworks to kind of help bridge the divide between those two?
Yeah, I think it's a great question. And maybe my answer is overly optimistic, but I think the tools we need to do effective scaling are there. Yes, when you think about it, the monitoring you do at an individual forest stand, it feels very hands-on. You're out, boots on the ground kind of stuff. But it is the same equations and the same measurements, more or less, height instead of diameter, that feed into the maps that we can make with data from JEDI and similar resources. I talked about flux towers. Those are site level measurements, but there's been an awful lot of investment made over the years in aggregating data into networks that are very accessible and in developing strategies using other satellites that can sense more directly aspects of ecosystem fluxes to do that upscaling. But I think that I think it's possible, and I think it's really pretty important if we want sort of what we learn from project scale MRV to be aligned with the goals of policies set at landscape, regional, and continental scales.
Great, thank you for that answer. And I'm going to build off of that a little bit and open it back to the rest of the panel. And we've had a couple questions I'm going to try to summarize together. So obviously there is this need for transparency in the standards and methodologies that we're using. And maybe, Jason, this would be most relevant to you, is thinking about what is kind of the role, let's say, of forest industry to help with the transparency of that, to better inform maybe the next generation of those standards? And then I would say follow up, John, if maybe you want to jump in there as well with some of the work you've been working on with the dynamic baselines.
Yeah, Chad, I mean, I think part of the reason that Weyerhaeuser entered this space was to bring some of that that we've been doing a long time. We've been measuring inventory for a long time, and it's gotten so much better over my career. I mean, I'm amazed at when I think back to when I started to where inventory is now. And so we've built these robust systems and inventory, and it's not just going out and measuring inventory, because a forest is dynamic, it's always changing. And so you've not just built inventory, but you've built these systems for your silviculture changes, your new seedlings. You're thinking about yield tables for those. Your trees are constantly growing, and we're constantly harvesting and planting. And so there's a lot going on. And so I think if we can bring some of that into this space and into how we're doing it, it feels like the methodologies are a little behind where we are managing things as industry on the ground. And I think, we're working with the registries to talk through some of that. And so, again, it goes back to that collaboration and working through and helping folks understand, what the opportunities are, at least from our side.
Yeah, I'm not sure I've got anything to add to that, Chad.
All right, I'm going to just have one last question for the group. So we have a question in the Q&A. Does ex-ante forest carbon forecasting modeling, does that fit it formally into MRV frameworks? Or are those primarily used outside of the core crediting system and more for like planning or scenario analyses?
I can speak to that a bit. So in the ACR in the current 2.1 improved forest management methodology, the forecasting, the baseline model is part of that framework, with the expectation that it gets updated with new information going forward. And so part of part of the inputs into that baseline modeling incorporate one of the options is to actually look at comparable properties and to evaluate how those lands are managed and quantify that in some way. And so we've done that trying to use Forest Service FIA data as a way to quantify what's the typical harvest behavior over the past 20 years in terms of frequency and intensity, and that can be used to inform those models. But we also use that information in terms of thinking about practices to implement that are potentially natural climate solutions, ones that perform better than the business as usual from a carbon perspective. And so while those aren't necessarily built into the voluntary carbon market, using those remote sensing tools or Forest Service FIA data are critical to understand how do we change practices going forward, and what'll actually pass muster as an improved forest management practice when you implement a project. And so those, I guess, all the data and those tools are inherent in developing a project and trying to understand what's going to give you the best opportunity to yield carbon benefits if you implement those on your land base. And I'm sure, Jason, there's a lot of scenario modeling and optimization that goes into your work, which is essentially that kind of body of work.
Yeah, there is, John, you're right. We run internal harvest schedules already, and we've been doing it for a long time. That's when we have teams of biometricians, and we're constantly trying to upgrade our inventory and get better at understanding, what the future is. And so, I think we're pretty good at that already. We know we have a really great history. We keep, more metrics than you would believe on our harvest. And then we are also constantly looking at what's coming up to sustainably manage our land. If you think about a company like ours that's publicly traded, we have to think about those things because we have to tell our investors what's coming. We can't just shock somebody with our harvest plan 5 years from now. And so we're always thinking about where that's going to go in the future. And so that's part of, if you think about that baseline of building that out, is matching that baseline to, what you were actually going to do. Even if you update that baseline, I think that may be an important part, because we certainly update our internal harvest schedules from time to time, but it doesn't bounce around a lot.
So we are rapidly approaching the hour mark, so I would like to take this time to again thank our panelists today. Thank you for taking the time and sharing some important context on this topic. I'd also just like to highlight our 2 upcoming webinars as well in May and June. The bottom QR code will take you to the Learning Exchange Series website, where you can also view the complete catalog of all of the Learning Exchange Series, which date back to 2017. The recording of this as well will be posted in the near future. So again, thank you all for attending, and thank you again to our panelists for helping out. And I hope everybody has a great afternoon.
Thank you.
Thanks.
Thanks, everybody. Bye.